I'm John Baker with another NX Quick Tip. Today we're going to talk about a little bit more complicated problem. What I have here is an engine compartment that we've designed, and there's a radiator in here, and we have to account for it as part of the design that eventually this car will be maintained, and one of the things that may be required is to replace the radiator. And so I want to be able to know whether I can get this radiator out of here easily. So I could go in and just grab the component just like any other component and just try to. They say, well, no, look at it. It's obviously it's interfering there. So I'm going to try to bring it back far enough to where it's not going to interfere. Well, now it's getting it's still going to. No, this is just not going to work out. So let me take advantage of a tool that we have here that will allow me to actually compute an extraction path. So I go to the assemblies module. I go into sequencing, and we're going to create a new sequence, and I'm now going to go into the extraction path function. And so we pick the object that we're going to extract, in this case the radiator, and then I grab a hold of it and I want to position where do I want the radiator to be after the extraction is completed. So basically I'm just going to bring it out here as if it's now being held by the mechanic. So I say, okay, that's fine. So now I can say this is where it's at now, and this is where I want it to be. So I want to go from that position to here and let the system compute that. Now, I could just let it go, but I want to put a restriction on here, a constraint. I don't want this to have to be put onto a lift. So I'd rather have them be able to pull the radiator out of the top. So rather than have the system think that it can get it out the bottom, which actually looks like it'd probably be the easiest route, I'm going to limit that. So I'm going to simply say, don't go out the bottom. So what I've done is here is I've got an area of working space, and I'm going to extend the upper working space. I'm going to give them lots of room at the top, which basically means they can only really stay inside this blue box here. So, okay, so that we got that all set up. So let's go ahead and actually start computing the path. So it's an iterative process. So what's it's doing is trying all possible cases, and there is a clearance. See, it found a solution. So now what it's doing is it's optimizing that solution in order to get the least number of motions, the shortest possible path, and so on. So now we have our answer. Now I can play it back, and it's kind of fast. So why don't we save that sequence, and now we'll just play it back using the normal sequencing tool. So you can see how this is being pulled out, and you see it's being jockeyed around in order to miss everything, and that's kind of expected. Of course, I can also play it backwards, and this would be the how would I go about putting a radiator in here and missing everything. And so there's the sequence. So that can be played back and forth. You can use it as part of let's say an online instruction manual. It could be used just as a study, and so on. You can try different alterations and so on. But one of the things that's kind of cool here is that I can create a volume of space that actually represents where the radiator has moved, and this actually might be more useful. So what I do is I'm going to go ahead and pick this and ask the system to compute it, and what it's going to do is going to create a lightweight faceted body that represents the volume of air or space that the radiator actually passed through as it was being moved. And so as I play this, you can actually see that it's inside of this envelope here, and so on. Now, the value of this is that if later on, now I can save this envelope, and I can save it in a separate part file, or I can save it as a component as part of this assembly. And later on, if I make a design change, or somebody comes up with has to add an additional feature maybe to the automobile, and we're going to have some more components under the hood, we don't have to go through all of this computation again. I can just simply say, does it interfere with this space? Even though it's a lightweight body, I can still do clearance analysis, interference checking, and so on. And if it clears that lightweight body, then we know that it's still safe. If it does interfere with it, then we're going to have to look at the parts that are being designed and maybe make changes, or we could go back and say, okay, fine, let's go back and test it and see if maybe I can still get it out. Might have to follow a slightly different path, but I still might be able to get it out. But you saw how fast the tool worked, so actually that wouldn't be a problem to go back and maybe try several different things as the design progressed and as different options was added to the automobile. So anyway, so that's a look at some capabilities that have been part of NX for a while. but we thought it'd be important for showing people some of the more advanced functionality that's available with NX. Thank you very much.